we will discuss the addition of two harmonic motions and beat phenomena. As we discussed that what is simple harmonic motions, when we are going to add the two motions, what are the resultants that we are getting out of these two motions? So, the contents of this lecture will follow the simple harmonic motion, we will recall it, and then the phase difference, and then we will discuss the addition of two synchronous harmonic motions, means they have the same frequencies. Of course, there will be phase difference in the two motions. Then we will discuss additions of two near synchronous harmonic motions, means the difference between the two frequencies is slight, and this will give give rise to the phenomena like beats phenomenon, and then we will derive the expressions for these motions. So, here we recall the simple harmonic motion, that simple harmonic motion is the motion, a periodic motion that a particle makes, okay, when the acceleration is proportional to the distance from the mean position and it is directed towards the mean position, and the simple harmonic motion is usually expressed in terms of sinusoidal or cosine motion. Like here we can see that we have two simple harmonic motions. So, x1 equal to x1 sin omega t. Here this small letter is showing the overall function of this motion, and capital X is showing the amplitude of this simple harmonic motion. Then we have the second motion x2, that is x2 sin omega t plus phi. So, these two motions have different amplitudes and there is phase difference. So, this motion x2 is leading with phi radians to this x1. So, we can see here, so this is a vector diagram. So, we can, on the vector diagram we can see, so this is x1. So, both have the same frequency. So, the both vector, this OP1 and OP2, they are moving with the constant angular velocity omega. OP1 has this omega t, this theta, and OP2 vector, that is the angle omega t plus phi, and this is the corresponding simple harmonic motion plotted on the theta axis. Now, we want to add these two motions. What is the resultant of these two motions that we have to find out? So, these are the two motions and we want to add these two motions. So, let us say that this is the resultant x, that is x1 plus x2, and so we can write x1 sin omega t plus x2 sin omega t plus phi. Now, these two motions have the same frequency, therefore, the resultant motions will also have the same frequency, and therefore, let us assume that the resultant motion is also harmonic. So, it is x sin omega t plus some phase, different phase angle beta. So, now we will solve these equations, because we have, if we want to know the resultant, we must know x and we must know beta. So, we can write this So x1 sine omega t, we can write this like x2. So sine a plus b equal to sine a cos b plus cos a sine b. So we can write sine omega t cos phi plus cos omega t sine phi. And here also we can open x, so sine omega t cos beta plus cos omega t sine beta. Now we separate out the terms. So let's here we write sine omega t and here we can write x1 plus x2 cos phi plus cos omega t into x2 sin phi. Now let us say this is equation A. Now we compare the from both sides the coefficients of sin omega t and cos omega t. So here we can write, here the coefficient of sin omega t is x1 plus x2 cos phi, here it is x cos beta. So we can write x cos beta equal to x1 plus x2 cos phi, and similarly we can write x sin beta equal to x2 sin phi. So these are other two equations, let us say B and C. Now we want to know x and we want to know beta. So we will do square and under root. So we do here x square cos square beta plus x square sin square beta equal to x1 plus x2 cos phi whole square plus x2 sin phi whole square. Now x square, we know that cos square beta plus sin square beta equal to 1. So cos square beta plus sin square beta equal to 1. Therefore we can write x square equal to x1 plus x2 cos phi whole square plus x2 sin phi whole square. So from here we can find x equal to under root x1 plus x2 cos phi whole square plus x2 sin phi whole square. So here we have got the amplitude x, and this we know x1, x2 and we know phi from these two motions. So we can also find the x. Now we have to know the beta. So beta we can know if we divide, so equation C by equation B. So we can find like x sin beta upon x cos beta equal to x2 sin phi upon x1 plus x2 cos phi. So here x will be cancelled out and we will have tan beta equal to x2 sin phi upon x1 plus x2 cos phi. So here we can find beta equal to tan inverse x2 sin phi upon x1 plus x2 cos phi. So here we have got x and we have got beta. So we have got the resultant, that is addition of the two motions. So it means that the addition of the two motions is x sin omega t plus beta, where x is under root x1 plus x2 cos phi whole square plus x2 sin phi square under root, and beta equal to tan inverse x2 sin phi upon x1 plus x2 cos phi. So the resultant of two synchronous harmonic motions is a harmonic motion with the same frequency. So here we discussed the addition of the two synchronous harmonic motions. Now we will discuss the addition of the two near synchronous harmonic motions, means there is slight difference in the frequencies of the two motions. So when two harmonic motions with frequencies that are very close to each other are added, so they exhibit some phenomenon that is known as beat phenomena. And if there are two motions, so x1 equal to a sin omega 1 t and x2 equal to b sin omega 2 t, where a and b are amplitudes of the two motions and omega 1 omega 2 are the frequencies, and omega 1 and omega 2, when they are slightly very close but not the same, then the beats phenomena occurs. So if omega 1 and omega 2 are different, then the resulting motion is not sinusoidal, and when they are slightly different, the phase difference vector rotates continuously and keeps shifting. So at certain instant of time, when they are in phase, the resultant motion is maximum, that is amplitude is maximum, that is a plus b and sum of a plus a and b, and when they are out of phase, the amplitude is minimum, and that is the difference of the two amplitudes of the two motions. So we will now write the equations for the beats phenomena. So we have two motions, x1 equal to a sin omega 1 t and x2 equal to b sin omega 2 t. The resultant motion, we want to get x equal to x1 plus x2, that is equal to a sin omega 1 t plus b sin omega 2 t. Now here we have assumed that omega 2 minus omega 1 equal to delta. a very small quantity. So here we can write omega 2 equal to omega 1 plus delta. Then we write x equal to a sine omega 1 t plus b sine omega 1 plus delta t equal to a sine omega 1 t plus b. Here sine a plus b, so we will open it. So sine a, so omega 1 t cos delta t plus cos omega 1 t sine delta t. So we can separate out the terms of sine omega 1 t. So we can write a plus b cos delta t to sine omega 1 t plus b sine delta t into cos omega 1 t. So now we want to know the amplitude. And the amplitude will be equal to this square plus this square under root So here b square cos square delta t and here is b square sin square delta t. So we can write b square cos square delta t plus sin square delta t, and cos square delta t plus sin square delta t equal to 1. So it will be b square so it is like a square plus b square plus 2ab cos delta t. Now when cos delta t equal to 1, because this is cos delta t varies, cos delta t varies between 0 and 1, 0 and minus 1, minus 1 and 1, it varies between minus 1 and 1. So when cos delta t equal to 1, the amplitude equal to root a square plus b square plus 2ab, and so it is a plus b whole square under root. So it is equal to a plus b. When cos delta t equal to minus 1, amplitude equal to root a square plus b square minus 2ab, because cos delta t equal to -1, so it is minus 2ab, and we can write under root a minus b whole square, because a minus b whole square is a square plus b square minus 2ab. So it is a minus b. So therefore, when we have the two motions x1 equal to a sin omega 1 t and x2 equal to b sin omega 2 t, the resultant motion will have the maximum amplitude a plus b. So resultant amplitude continuously keeps on changing from maximum, that is a plus b, to minimum, that is a minus b, with a frequency that is equal to the difference between the individual component frequencies. So this phenomena is known as beats. Now let's take a special case. So let's take a special case when a equal to b equal to x. So we assume that the amplitude of the two motions is same. So let's write this expression. So here we will have amplitude equal to under root x square plus so here it is a square plus b square plus 2ab cos delta t. Now we put a equal to b equal to x, so it will be x square plus 2x into cos delta t. So it is equal to 2x square plus 2x square cos delta t, so equal to under root 2x square 1 plus cos delta t. So we can write equal to under root 2x square 1 plus cos 2 theta equal to 2 cos square theta minus 1. So here we write cos minus 1. So we will use this this formula to open to break this term. So 1 plus 2 cos square, here 2 theta is delta t, so theta is delta t by 2. So here we can write delta t by 2 minus 1 minus 1. So this 1 and 1 will cancel out, and we will get 4x square cos square delta t by 2. So here we can have this equal to plus minus 2x cos delta t by 2. So here we see that the amplitude varies as a function of cos delta t by 2, and we can see this from clearly from this diagram. So here this is the resultant wave that is moving. However, the amplitude is moving in a cos delta t manner because it is a function of cos delta t by 2. So this is a cosine, so here is maxima and this wave is moving, and then the next maxima is coming here. In between these, we can see that there is the beat. So, beat can be considered as the time period between these two nodes or two maximas. Okay. So, therefore, the beat frequency, beat time period is half the time period of the cosine curve, or the beat frequency is twice the frequency of the cosine curve, that is 2 times delta by 2, that is equal to delta, and delta is, we assumed, omega 2 minus omega 1, that is the difference between the two frequencies. And so, here when we have same amplitude, so we see that the maximum is 2x, then minus 2x, and here this minimum is 0 here. And so, the amplitudes builds up, so amplitude is builds up, so here it is building and then diminishes in a regular pattern. So, therefore, we, whenever the two motions, two harmonic motions with the closed frequencies are there, they will show the beats phenomenon, where the amplitude will build up and then it will diminish in a regular pattern. So, we would stop this lecture and we will meet again. Thank you for your attention.